Hi, my name is Muafiq bin Ahmad Syahudin from class DKM 3C. My metric number is 08DKM19F1095. Today I want to talk about sample preparation. The first one is what is the theory of sample preparation? Okay. Metallography consists of the study of the constitution and structure of metal and alloys. Much can be learned through specimen examination with the naked eye, but more refined technique require magnification and preparation of the material surface. Optical microscopy is sufficient for general purpose examination. Advanced examination and research laboratory often concern electron microscope, SEM and TEM, X-ray and electron diffractometer, and possibly other scanning device. Okay, this module take the student through the metallographic sample preparation process step by step with demonstration and explanation of sectioning, mounting, cost and fine grading, polishing, etching and microscopic examination. Sectioning. Operations such as shearing produce several coolwork which can alter the microstructure of a sample. Abrasive cutting offers the best solution to eliminate these undesirable features. The resistant surface is smooth and the sectioning task is quickly accomplished. Low-speed cut-off wheels are utilized in cases where the heat created by standard abrasive cutters must be avoided. Ample coolant and proper speed control are essential in all sectioning operations. Mounting is small samples are generally mounted in practice for convenience in handling and to protect the edge of the specimen being prepared. Compression type molding is commonly applied to encased specimen in 1 to 1.5 inch diameter plug of hard polymer. Compression molding materials are classified as either thermosetting and thermoplastic. Coarse grinding. In view of the perfection required in an ideally prepared metallographic sample, it is essential that each preparation stage be carefully performed. The specimen must be free from scratch, stain and other imperfections which tend to the marked surface. Number 2, return non-metallic inclusion. Number 3, reveal no evidence of chipping due to brittle intermetallic compound and paste. And be free from all trace of disturbed metal. Medium and fine grading. Medium and fine grading of metallurgical sample are closely allied with the coarse grading which precedes them. Each stage of metallographic sample preparation must be carefully performed. The entire process is designed to produce a scrap-free surface by employing a series of successfully final abrasives. Failure to be careful in any stage will result in an unsatisfactory sample. Mechanical polishing. Polishing involves the use of abrasive suspend in a water solution on a cloth cover electrically powered wheel. Diamond abrasive provide the best and most expensive compound utilized in polishing. Standard size aluminum oxide powder are applied for general use purpose. Following the final 600 grit fine grading stage, the sample must be washed carefully dried before proceeding to the first polishing stage. Beginning with 25 micron suspend aluminum oxide particle on a nylon cloth, the final fine grinding surface layer sustained for the previous grinding procedure should be completely removed with a rotation rate of 150 to 200 rpm. Last step is etching. Microscopic examination of a properly polished unetched specimen will reveal only a few structural features such as inclusion and crack or other physical imperfection. Etching is used to highlight and sometimes identify microstructural features of present. Even in a carefully prepared sample, a surface layer of disturbed metal resulting from the final polishing stage is always present and must be removed. Agents are actually dilute acid or dilute alkalis in a water, alcohol, or some other solvent. Etching occurs when the acid or base is placed on the specimen surface because of the difference in rate of attack of the various press present and their orientation. The etching process is usually accomplished by merely applying the appropriate solution to the specimen surface for several seconds to several minutes. Metallography technique like apparatus. Number first, abrasive cutter machine, polisher, lubricant, ultrasonic cleaner, soapy water, needle solution, optical microscope, grinder, silicone carbide paper, diamond spray, dryer, cotton, alcohol, and sample made steel. Procedure. Number 1. Grinding is done using rotation disc cover with silicone carbide paper and water. Number 2. During grinding, apply light pressure on the center of the sample. Number 3. Wash the sample in water and move to the next grid orientation the starches from the previous grid normal to the rotation direction. Number 4. Repeat the grinding procedure until the final grinding operation. Number 5. Polishing is done using rotation disc cover with soft cloth impregnated with diamond particle and lubricant. Number 6. Wash the sample under running tap water followed by cleaning with alcohol. Immerse the sample in ultrasonic cleaner for 1 minute, then dry the sample. Number 7. Repeat the same procedure for final polishing stage using 1 micron lubricant. Number 8. Examine your sample by using optical microscope. Note down your observation. Number 9 and the last one, number 9. Immerse the polished sample in the etching solution for about 2-3 seconds. Wash the sample with water followed by alcohol. Dry the sample prior to microscopy examination. Precaution. While using the microscope, be careful not to raise the stage too much, which may result in contact between the objective lens and the specimen and can cause damage. Never touch the optical surface with your finger or with any object. For discussion, to obtain a good sample of the specimen, following precautions are needed to be taken. Before analyzing the sample, it is necessary to follow above steps carefully, as listed in the introduction. Different materials need different grinding technique and different lubricant. Also, when polishing agent may depend on the material. When it comes to etching chemical solution and procedure to etching also depend on the material. When sectioning and grinding, the heat need to be minimized to avoid alteration of the surface properties. Usually when sectioning and grinding, water is used as a coolant. The microstructure is the small-scale structure of a material. This can be seen on prepared surface by a microscope above 25 magnification. The microstructure of a material can strongly influence physical properties such as strength, toughness, ductility, hardness, corrosion resistance, high or low temperature behavior, or wear resistance. By examining microstructure and using microetching, following can be identified. For conclusion, as a result, this change in the material properties and processing technique are very important for the microstructure. So, metallography has an important place in material science because of interpreting of microstructure and making important changes that affect physical properties of material. Thank you.